In this problem, we're given the coefficient of friction for plastic on wood. These numbers are completely made up, by the way. This coefficient of static friction is 0.84. The coefficient of kinetic friction is 0.27. The horizontal force that you need to apply to move this calculator is what? So let's draw ourselves a free body diagram. If I have my calculator sitting on a tabletop, then this calculator is going to experience a force of gravity. It's going to experience a normal force from the table pushing up against it. We're going to put our hand on this and we're going to apply a force, let's say, toward the right. Well, if we're trying to push the calculator toward the right, then the friction is going to be toward the left. We want to start this calculator in motion. So to get this calculator started in motion, we're going to have to overcome the static friction. So if we just want it to begin to move, right here, then we need to say, okay, well, my net force is actually going to equal 0 because we're just at the point where we want this calculator to begin accelerating. And what that means is we take the force that's being applied minus the static friction, that total is 0, or that those two forces are going to balance each other out. And then what we'll really know is any force greater than what we're about to solve for will actually put the calculator into motion. All right, so if we think about the static friction, right, I should label this, these are the net forces on the x-axis. Let's talk about the net force on the y-axis. This calculator is not going to accelerate up or down. So the normal force minus the force of gravity is going to equal 0. And so those two forces likewise are going to balance one another out, that the normal force is equal and opposite of the force of gravity. That's not an action-reaction pair, by the way. All right, so far we have two equations. Well, also we know that static friction is equivalent to the coefficient of static friction times the normal force. And so now with these three equations, what I want to do is say, okay, well, this problem never told me the normal force, but I know that normal force equals the force of gravity. And I know that I'm trying to solve for the force I'm applying. Well, that just so happens to equal the static friction here. So what we really know here is now that the force being applied is equal to the coefficient of static friction times the force of gravity. And so this coefficient of static friction, 0.84, times the mass, 0.3 kilograms, times acceleration due to gravity, 9.8 meters per second squared. So 0.84 times 0.3 times 9.8, we get a force right here that's equal to 2.47 newtons, or 2.5 newtons. 2.5 newtons would cause this calculator to begin moving.